Hi, thank you for coming here today. I'll be talking about Copilots and their security implications, titled Copilots Need Helmets Too, GitHub Copilot Security Case Study. So really, we have 2 points on our agenda today. We'll be taking a look at the attacker's point of view, the defender's point of view, and here I have a confession to make. When I was researching this topic, I thought that I'll be applying lessons learned from the GitHub Copilot directly, but then I stumbled on the fantastic resource of OWASP Top 10 Risks for Large Language Models, which was just too good of a resource to pass up, so we'll be talking about that as well, and sprinkle some general advice in the end. So, hi, my name is Miroslav Holmer. I'm a senior application security engineer at Kiwi.com, and I'm also the tech ambassador for the security topic for this year, so that's why I'm here. You can find me on LinkedIn. I have a small personal website, miroslavholmer.cz. And yeah, I was tasked with researching GitHub Copilot for our uses within our company. So the idea was, can we use these new technologies safely? I'll try to answer that question in the linked article. So if that's something that you'll be interested in, feel free to grab the QR code and read it at your own leisure. Today, I'll be more focused on how to build a secure product rather than using this one piece of technology. So I'll wait a couple more seconds, and once I see you stopped screenshotting, I'll move on. Basically, the short answer is yes, but there are some gotchas, as the default configuration of the Copilot plugins is really permissive in sending the data to the third party, which is something that isn't really pleasant from the security perspective. Okay, a couple more photos. One more. Great, fantastic. So, taking a look at the attacker's view. So what am I even talking about when I talk about copilots? I am talking about so-called T clients. That means it's an application that has a logic client side. The attacker has access to this logic in one way or another, be it JavaScript, be it some compiled code, be it a mobile application. And this application is making a few calls home or to the large language model. This creates some new risks. So think about plugins. That's like the most obvious definition for a Copilot, and it's the one that we'll be taking a look today. It's something that runs in your existing tool that enhances your existing workflows. But also think about mobile apps as a platform for sharing and building new solutions within your day-to-day functions. But the lessons here are also applicable for front-end heavy websites where a lot of JavaScript is sent to the client and the client is making some decisions. Maybe now's a good question to ask how technical this audience today here is, who is kind of comfortable with web technologies. Oh, fantastic. No breaks needed. That's excellent. So yeah, the main characteristic of these T clients is that they are making a few expensive API calls home, because the large language models are, well, expensive calls. They take a long time, they are pricey. And another specific of these is usually they need to accept and return free-form text. You don't really have a strict format. That's something that Andre mentioned in his talk, that you need some tricks and whatnot to parse the format, to send the format, as opposed to well-defined API calls that you would find in other APIs that you are working with and used to. So yeah, let's take a look at the attacker's view. Usually when we are talking about a client, we have two approaches. The first approach is static analysis. Just take a look at what you have in your hands and try to analyze it, try to reverse engineer it, try to say anything intelligent about it. And the other approach is so-called dynamic analysis, really just opposed to the static analysis, where we will insert a proxy between the client and the server, and we'll be taking a look at what requests are going where, what's inside, how can we manipulate them, and what can we do with the responses. So yeah, let's take a look. And around here. So first, let's take a look at the static analysis part of things. And I'll be talking about GitHub Copilot. That's a plugin that you can use in your IDEs. And it's built upon JavaScript. We'll get to that in a moment. It's freely downloadable. In particular, I'll be talking about the plugin for NeoVim, which is a text editor under Linux. It's the simplest plugin of them all. That's why I've chose it. But from what I gathered, other plugins are similar, at least in the sense that the agent core is the same, but the bindings to the particular editors are, of course, different. So I have the plugin downloaded in this folder. And yeah, there is a lot of bindings and technical work to be done, so it works well with the editor, but we are interested in the core of the plugin, the agent that talks with the large language models. That's in the JavaScript file agent.js. So a follow-up question, how many of you are comfortable with JavaScript? Wow, fantastic. So maybe you can tell me what this is. Because I don't know. Well, actually, I do know. This is minified JavaScript, and it's notoriously hard to read. It's more akin to a compiled code, and you really need to do some kind of reverse engineering and analysis to figure out what the functions are about, what is the logic, how to properly read it, and how to get some kind of insights from it. And it takes a long time. It's not easy. It's a big product. It's very well optimized. It's made by Microsoft. Microsoft, out of all folks. But still, there are some things that we can get from this file. At the bottom of the file, there are some comments with known libraries and their licenses and whatnot. That's not really that interesting, but it's there. Sometimes it helps. Shout out to Jan Hruby. Okay, so a few more lines, and we are in this fantastic section. So what can we see here? We can see some prompt engineering content that is used to enhance the Copilot answers. Basically, around here, we are taking a look what happens when the Copilot is asked to document the current selection of the code. So this is how the agent enhances the prompt so the user gets a better answer, like write documentation from the selected code. The reply should be a code block containing the original code with the documentation added as comments. Use the most appropriate documentation style for the programming language, etc., etc., etc. There are a few other of these prompts for explaining, for fixing. That's very desperate, but it is there. So you can take inspiration from this, and yeah, all of the logic is present in these JavaScript files, but a full reverse analysis of the solution is really out of scope of my capabilities. So let's take a look at the dynamic analysis then. As I mentioned, I got the NeoVim plugin configured for this specific talk, and let's see how it actually works. So I'm editing a Python file. Yes, and it recommended me to continue with Python, which is awesome. Not really author. That's wrong. That's correct. So you can see that it recommended me to continue with this snippet. And that's the plugin in action. It recommends you the text that is most likely to be continued based on the file. And now let's take a look at how it looks on the proxy. So this is a Burp Suite proxy tool. It's a proxy in the literal sense. It sits between the plugin and the internet. And we can see all of the requests that this plugin is making. To start things with, we can see the initial handshake when it checked that I don't really have a Copilot license. So it's good it checked that. So I promptly fixed the error with our procurement department, and suddenly I am authorized and I can get the token and whatnot. And the life is good. There are a couple more requests. We can get to the telemetry, for example, which is currently Yeah, we can go over telemetry right now. So this is telemetry. It's not very readable because it's a gzip format, but I have it unpacked around here. Yes, and once unpacked from the gzip format, it's a NJSON format, like it's a file and each line is a separate JSON. So to take a look at one of these entries, you could chain the commands like this, take a look at first 3 lines, take a look at one line, and then parse it so it's prettier. And we can see that really it's a big entry that contains many different pieces of information about your client, about the version of the runtime, about the event, what's going on, the editor version, plugin version, Copilot version, runtime version, extension name, extension version, it's all there really. So that's another thing to keep in mind. Not only calls to large language models can contain sensitive data, but there are also other channels that can be used for data transfer. But we are here for the large language models, and that's handled by this endpoint. And it's looks like this, really. The prompt is basically the context of the file, the contents. It prefixes the contents by the file name and the path. So the Copilot knows where it's located in the projects. There's a suffix if applicable. It wasn't because I started a new file. And there are some settings to the model, like maximum number of tokens, the temperature, and whatnot, and some extra data, like it correctly identified the Python language. So here is the responses, and this one is really simple. It really recommends the one and only possible continuation, and that's Python. So that's the HTTP request and response of the call. So this is the point where we would try to misuse it somehow, because this is the point where we interact with the models. So as an example, I try to hijack the logic of the extension to do something else that provide coding advice, because I know coding, I don't need coding advice, I need a general large language model. So I asked the model what a haiku is, and to help him and to get him started, I prefixed it with the start of the sentence, so he really knows he should continue in this manner, because really these things predict the next most probable word that really helped him get the answer right. So the first recommendation is an empty string, nothing, 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 and then he starts. A haiku is a Japanese poem of 17 syllables, comma, in 3 lines of 5, 7, and 5, traditionally, and so on and so forth. So yeah, this is a simple example of a prompt injection that hijacks the logic of the original intent and the model. So I think we can conclude the demonstration here and get back to talking. Cool. So what can we do about this? As I mentioned, I've stumbled upon this great resource that is OWASP Top 10 for large language models. And if you don't know OWASP, it's a non-profit organization that aims to provide secure methodologies and cheat sheets for the general public. So, of course, they have one for the large language models. This is the order they deemed important as the most important to the least important, but it's kind of all over the place, so we'll be jumping a bit so it's more topical. A few of you will have the following problem. You are going to build your own model. Who is going to train their own models? Okay, so let's get over this quickly. Beware of model poisoning, because you don't want to have attacker process data in your model that can change your responses. And also protect your model, because the training phase is very expensive. You also need to deal with supply chain issues, like having third-party dependencies that will break your security, and also really just treat your weights, your output of the training as a trade secret, do all of the regular protections, don't give it anywhere, and so on and so forth. Since you are not doing that, let's move on. The most novel of these techniques, and probably the most interesting, is the prompt injection. Because the logic of the large language models is really not that deterministic. You can try, and you will most likely then not succeed in manipulating the prompt to change the instructions of the original model. There are two fantastic, well, there are surely more, but I'm listing two fantastic games where you can try it. Basically, each of these games has a guardian of the secret that has its instructions, and you need to use these prompt engineering tricks to try to get the agent to reveal the secret to you. Needs to be said here, do not use large language models for cryptographical purposes. Do not use them to store secrets. Do not use them to check passwords. Thank you. So, from my point of view, the most serious threat is the denial of service or the denial of wallet, because these calls are expensive. So, what can you do? You can rate limit. You can rate limit per user, and you should also have a global stop rate limit for all of the calls that reach your application. It is a simple precaution. It is efficient precaution. You can then budget your calls, your money, and your attention span to your customers. Do not give the users the API keys to your model. Needs to be said, needs to be said. Not even in mobile apps, those are reversible too. So, yeah, that's that. And of course, these plugins or applications and whatnot are still normal applications. So you'll need to consider the applicable categories in your solutions, such as insecure output handling. This one is especially tricky because you need to deal with free-form text. You don't really have some kind of format or whitelisting or enumerations to lean on, or encoding. You need to accept the raw string and need to think harder about what is valid for your model and what is not. As we saw, not even Microsoft was able to nail this down completely properly, as I was able to use some trickery to get their coding model to output some non-coding advice. But when you start building agents that can actually affect the state of the applications and the real world, you'll start running into permission issues. Should the agent be able to do that? Or maybe should not, or maybe it should. Speaking of plugins, the plugins themselves can have some issues. It's still software, you know. So you can use applicable methodologies based on what you are building. There is a fantastic OWASP web security testing guide for web applications. It has relevant parts for the front end as well. If you are building a mobile application, check out the OWASP mobile security testing guide as well as a comprehensive guide to secure your apps. And don't forget about the end user. Basically, it's concerns with privacy and the sensitive data, most likely. As we saw, not only you need to take care about the calls to the model, think about other channels such as telemetry as well. You will usually be covered here by some kind of terms and conditions, like we don't want to process the secret data. They will send it anyway, but it's all of the legal stuff that I'm not really qualified to talk about, so consult with your own lawyers if you are doing something like this. You will be opening a whole new can of worms when you will be dealing with the agency, and you will be able to make changes that affect other applications or the user assets. So think about the minimal scope that you can give to your agent, whether the agent is able to somehow misuse the permissions or whatnot. And there is also a non-solvable question of reliance, like how much can you really trust the output of these large language models? It's an open question. I don't think there is an answer. And that concludes the methodology overview. If you have any questions, shoot them up. You can also find me on LinkedIn or check out my webpage. And if you can't think about the question, I'll be around, so just put a note on my shoulder and ask away. Thank you very much.